So in this lecture, let us see how to analyze a pin jointed truss using method of joints. So determine the force in the members of the truss shown in figure. So here this end is fixed. So we have joint A, joint B, joint C and joint D. And there is a vertical load of 10 kN applied at joint A. So we need to find the forces in the members of the truss, that is force in member AB, force in member AD, force in member BD and force in member BC. We need to find. So in the method of joints, we need to consider equilibrium of every joint. So let us start with the free end. So this truss is considered to be a cantilever truss since it is fixed at one end and it's free at the other end. It is a cantilever truss. So in case of cantilever truss, we can start from the free end. So the free end is A. So consider joint A. We are considering joint A. So we need to draw the free body diagram of joint A. So free body diagram is a diagram which includes all the internal and the external forces acting at a joint. So the external force will be the applied loads. Say at A there is an applied load of 10 kN. So this is the external load. And due to external load, the joint A will deform. So when the joint tends to deform, the members connected at the joint will try to resist the deformation. Thereby, some forces are formed in the internal forces are formed in the members AD and BD. So that internal forces are FAD and FAB. That is force in member AD and force in member AB. Likewise, at every joint, say for example, if we have B, so the due to the application of the load here, so joint B will subjected to deformation. So that to resist the deformation, the members meeting at this joint, forces will be set up in the members meeting at this joint to resist the deformation. Those forces are called as internal forces. So a diagram which shows the internal forces as well as the external forces of a joint is called the free body diagram. So we need to draw the free body diagram of joint A. So if you take joint A, you can very well see the free body diagram. At joint A, the external load is 10 kN and internal forces, say here we have member AB and FAD, force AD here. So force AB is marked like this and force AD is marked like this. And it is better to assume, say these internal forces FAB and FAD are unknown. So it is better to assume the unknown forces as tensile forces. So we can easily remember like this. That is, forces which leave a joint are considered as tensile forces and forces which act towards a joint are compressive forces. So for unknown forces, it is better to assume as tensile. So tensile means they should leave the joint. So we are assuming FAB as a tensile force. Similarly, FAD is also assumed as a tensile force. And the angle between these two is 60 degrees as per the given problem. So 60 degrees. So we need to consider the equations of equilibrium at joint A. So using joint A, say using the equation sigma V equal to 0, that is sum of all vertical forces equal to 0, treating upward as positive. So come to joint A. So see for the upward forces or vertical forces, sorry, not upward, vertical forces. So here we have 10 kN acting downward. So minus 10 should be taken when you use sigma V equal to 0. So minus 10. And this is purely horizontal force, so this will not have any vertical component. Whereas this inclined force can be resolved along the vertical axis. So we very well know that resolution of forces, that any vertical component will be in terms of sine theta, horizontal component will be in terms of cos theta, provided theta is with respect to the horizontal axis. So if I resolve FAB along y-axis, I will be getting FAB sine 60. FAB sine 60, and this arrow will be pointing up after resolving or upon resolving. So this minus 10 and this is plus FAB sine 60 will be sigma V equal to 0. So minus 10 is here plus FAB sine 60 equal to 0, from which we can find the value of FAB. So FAB equal to 10 by sine 60 will be 11.55 kN. Then using sigma H equal to 0, because for equilibrium, sigma V should be equal to 0. That is, sum of all vertical forces at a joint should be equal to 0 and sum of all horizontal force on a joint should be equal to 0. Therefore, using sigma h equal to 0, for this sign convention will be forces towards right will be considered as positive and forces towards left will be considered as negative. So using this equation sigma h equal to 0, let us go back to this joint A. So here FBAD is purely horizontal. So you can take as such. So FAD is horizontal and it is acting towards left, therefore minus FAD. And this FAB can be resolved along horizontal axis. So FAB cos 60. And when we resolve here, this FAB will be moving towards left. Therefore, this is also minus FAB cos 60. So minus FAB cos 60 equal to 0. And this will not come into play. 10 kN will not come into play while taking the horizontal component. We have these purely existing horizontal force and the resolved horizontal component. Only these two will come into play for sigma h equal to 0. So minus FAD minus FAB cos 60. So minus FAB cos 60 will be equal to minus FAB cos equal to 0. So minus FAD minus FAB we have already found as 11.55. Substitute the value of 11.55 cos 60. Therefore, you will be getting the value of FAD as minus 5.78 kilonewton. So after finding these two forces, the unknown forces using sigma v equal to 0 and sigma h equal to 0, we need to check whether they are compressive or tensile. So only after finding all the unknowns we should take this decision. We should not make it intermediate so that the calculation should be confusing. So you better make the decision after arriving the unknown forces. So after arriving both the unknown forces FAB and FAD, if we get plus value, then that indicates tensile force. If we get minus value, that indicates compressive force. So a compressive force will be acting towards the joint and a tensile force will be leaving the joint. That we should very well remember. So FAB equal to 11.55 kilonewton tensile. Tensile is marked as T. And FAD equal to 5.78 kilonewton compression or compressive. So we need to remove the sign. So either the nature should be there or the sign. So 11.55 tensile and 5.78 compression are the forces acting at joint A. Now moving to joint B, draw the free body of joint B. So here joint B is there. The left side we have FBC. This inclined side we have FBD. And here we'll be having FBA. FBA or FAB. This force is FBA or FAB. And FAB we have already found as 11.55 kilonewton tensile. So we should mark that 11.55 here. So actually it is marked here. It is not visible, but we should mark clearly. So here it should be marked. So how we should mark? Say this 11.55 is tensile. So with respect to joint B, the force should leave the joint. It should not move towards the joint. It should leave the joint. So 11.55 should leave the joint. So mark, use the arrow like this and write the value 11.55 kilonewton here. It is marked actually, but it's not visible here. So sorry for the inconvenience. So here there is a force of 11.55 kilonewton. And this angle is 60 degree. This angle is also 60 degree. Now we need to use the equation sigma v equal to 0, upward positive. So if you use sigma v equal to 0, upward positive, so we don't have any purely vertical force. We have two inclined forces. So these two inclined forces can be resolved vertically. And this is purely horizontal force. This will not have any vertical component. So if I resolve this, FBD sine 60, FBD sine 60. Here we have FBD sine 60. And when I resolve vertically, this arrow will move down. That indicates minus sign. Similarly, we have 11.55 kilonewton acting here. And arrow is pointing towards down. So if I resolve again, you will be going down. Therefore, minus 11.55 sine 60. All vertical components will be in terms of sine theta. Horizontal components in terms of cos theta, provided theta is with respect to the horizontal axis. So using this, we can find the value of FBD. So FBD equal to minus 11.55 kilonewton. Then using sigma h equal to 0. So going back to this, H, we have purely horizontal force FBC here. So to acting towards left, or we have assumed as a tensile. So minus FBC. And here FBD can be resolved horizontally. So if I take FBD horizontally, FBD cos 60 will be there. And this arrow will move towards left. Therefore, this is also minus FBD cos 60. And we have 11.55 acting towards this direction. So if I resolve this 11.5 kilonewton along horizontal axis, the 11.55 cos 60 will be there and will move towards right, therefore plus. So here we have all these things. 11.55 cos 60 is plus, minus FBC since it acts towards left, and this resolved component FBD cos 60 will move towards left, therefore minus. therefore equal to 0. Substitute the known values in this, we'll be getting the unknown value of FBC. After getting FBC as well FBD, now write the results. So FBD we have got minus 11.5 kilonewton, so remove the minus sign, write it as 11.5 kilonewton compressive or compression. And FBC we have got plus 11.5 kilonewton, it is tensile. So now say the internal forces FAB, FAD, FBD, FBC, all the four internal forces have been found. So after finding, we can mark the forces on the given truss like this. Say we have got FAB as 11.55 tensile force. So tensile force should be marked like this. Say we have a downward arrow, we have an upward arrow. Because we know that tensile force should leave a joint. Say if I take this joint A, this force is leaving. Similarly, if I take joint B, this force is leaving. So this is the tensile force or tension member. Then here we have found this as compressive force, 5.78 kilonewton. This FBD is 5.7 compressive. The compressive force should move towards the joint. So if we take joint D, the force is moving towards joint D. If we take joint A, the force should move towards A. Therefore, this compressive force should be marked like this. And here we got compression, FBD also compression. So compression should be marked towards the joint. With respect to both the joints, if we take a member, the convention of the tensile or compressive forces should be either both moving away from the joint, from both the joints, or moving towards both the joints. Compression will be towards both the joints. Say if we take joint B, this is moving towards B. If we take joint D, towards D. So therefore, this is compression. In case we get tensile here, say we have got tensile force here, FBC, 11.5 kilonewton tensile. So tension should be marked like this. With respect to C, the force should leave the joint. With respect to B, the force should leave the joint. So this is how we should analyze a truss using method of joints. Dear viewers, thank you for subscribing our channel and then share among your network so that everyone can utilize this Made Easy series. Thank you.